It was the event that launched the reality of bioterrorism into the consciousness of every American.
Anthrax.
Another anthrax case.
We could narrow the investigation to a very rare strain of anthrax.
In the fall of 2001, the United States began to experience a series of mailings of letters tainted with anthrax bacteria. By mid-November, authorities had identified 3 anthrax-laden letters. One addressed to the office of Senate Majority Leader Tom Daschle in Washington, D.C., one to NBC News anchor Tom Brokaw in New York City, and one to the New York Post, also in New York City. All the letters have been mailed from Trenton, New Jersey. In total, the letters killed 5 people and affected 22 others, spreading fear, anxiety, and panic across the nation. Just weeks after 9/11, Americans came face to face with an unfamiliar enemy, a bioweapon. Anthrax. This program, we're going to explore the history and science of one of the most dangerous pathogens known to man. We're going to learn why it's so effective, how it works, and how American defenses have changed ever since those letters were mailed in 2001 to combat this phantom menace. Ladies and gentlemen, my name is Lucas Heflin, and you're listening to FCRN, the Fall City Radio Network. Thank you for joining us. In the month after the tragic September 11th attacks in 2001, Americans had a new terror. An odorless, tasteless threat capable of wafting in at any moment. A puff of white powder was all it took. The threat, of course, was anthrax.
2 media offices and a Microsoft office received letters containing anthrax. 1 man is dead, 2 people are being treated for the infection.
Anthrax is a disease well known to ranchers and veterinarians, but much less so to the general public and physicians. To understand the role of anthrax, we must first look at bioterrorism as a whole to find out exactly what we're dealing with. So, to start us off, a question. What exactly is bioterrorism? Christy L. Koenig, a professor at the University of California, Irvine, and director of the Center for Disaster Medical Sciences, has our answer.
Well, it's the use of biologic agents to kill or sicken people, animal, or plants, but you have to have an intent that goes along with it. It can't just be sort of accidental. So you have to be intending to intimidate or coerce a government or a civilian population for some kind of political or social objectives. So there's something that goes with it as well as the effect of it.
In order for something to be classified as a biological weapon, it must be inexpensive but difficult to weaponize, a term I'll bring up again later, relatively easy to obtain, induce fear, capable of overwhelming medical and public health systems, and it must have a potential for dissemination over a large geographic area. From these characteristics, it's clear why a terrorist would want to get his hands on a weapon of this capability. The anthrax sent to the U.S. government back in 2001, in fact, halted everything. Congress, for the first time in history, stopped. And that was only 1 kilogram that he sent in those letters, as Colin Powell told the United Nations shortly after the anthrax attacks.
A teaspoonful of dry anthrax in an envelope shut down the United States Senate. Iraq declared 8,500 liters of anthrax.
Bioweapons clearly have a very destructive capability, but what exactly makes them so powerful? And in this case, what is it about anthrax that makes it so especially deadly? So, to begin, what is anthrax?
Mother of biological warfare agents, anthrax.
Okay, what is anthrax?
Well, anthrax, Doris, is a disease caused by infection with the gram-positive spore-forming rod, Bacillus anthracis.
That's the voice of a research scientist for the Air Force in an informative video for troops on anthrax. Simply enough, anthrax is a disease caused by the bacteria Bacillus anthracis, as he was saying. This bacteria is naturally occurring and is most often found in the soil in herbivores. In fact, veterinarians can often tell a possible anthrax-induced death in an animal by its sudden occurrence and by the dark, non-clotting blood that oozes from the body orifices. Needless to say, anthrax is an ugly disease. But the anthrax bacterium is unique for one other specific reason. It can form into a hardened spore-like structure, smaller than a grain of sand, and can survive extreme conditions. It is in this form that anthrax infects living creatures. Once the bacteria enters the body, they begin to germinate and form your generic rod-shaped bacteria that we're all used to. And it is in this generic form that they begin to produce toxins lethal to cells. Air Force Colonel Art Friedlander, a senior military scientist with the United States Army Medical Research Institute of Infectious Diseases, or USAMRIID for short, explains this process in that same video as before.
How does anthrax cause disease?
What happens is that the spore is the infectious form of the organism, and the spore enters the host, and then the spore germinates, that is, into a bacillus, a rod-like shape of the organism. And the organism then has the capacity to produce two toxins, the so-called edema toxin and lethal toxin, as well as a capsule. And the toxins interfere with the host response to the organism. And one of the key roles of the key players in the toxin is the so-called protective antigen. But it's the toxins that cause local damage to the tissues and the capsule that interferes with phagocytosis of the organism that enables the organism to survive in the host.
Okay. Colonel Edson, how does this translate?
Those three proteins that he mentioned, the edema toxin, lethal toxin, and the protective antigen, are what the bacteria releases that kill the host cells, causing what is called necrosis. Now, anthrax spores can infect human beings in three different ways: cutaneous, that is to say skin infection, pulmonary or lung infection, and gastrointestinal infection. Here's Colonel Edward Eitzen, Chief Operational Manager with USAMRIID, to explain cutaneous infection.
Which causes over 95% of naturally occurring cases of anthrax. And this is caused by spores entering breaks in the skin of the person infected. There is a natural progression of the lesion of anthrax from papule to vesicle to an ulcer to a black eschar.
And actually, just to stop it right there, it's this form of infection that gives anthrax its name. As Colonel Eitzen was saying, when anthrax enters the skin, it eventually leaves a black scar or lesion in the tissue. The word kol in Greek, after the black scars, is anthracus, which then denotes into anthrax. Anthrax is also known as wool sorter's disease because workers who sorted the wool of animals, like sheep, would contact the spores through tiny cuts in their skin. The spores would come from the animal hides that they were cleaning, and the black ulcers would show up within a few short weeks. Cutaneous infection is the most common of all infections, of about 95%, and has a mortality rate of approximately 20% if left untreated. It is thus the least lethal, least deadly of any of the forms of infection. Now, the second form of anthrax infection is gastrointestinal, but as the research scientist says, this is exceptionally rare.
Probably the reason it's so rare is that you have to get it by eating contaminated meat. And usually anthrax is a pretty rapid, pretty messy death, and most animals that would die of anthrax probably wouldn't be butchered for human consumption. So again, pretty rare way to get anthrax.
With cutaneous and gastrointestinal covered, this then brings us to the third type of infection, pulmonary, which is by far the most lethal and the most worrisome of all the modes of infection. I found Dr. Thomas Aragon from UC Berkeley School of Public Health to explain pulmonary anthrax.
The spore is inhaled, it goes deep into the lung, and then that spore then what's called germinates. It germinates and then it starts growing, producing not just toxins that can cause septic shock, but also causes a lot of necrosis and hemorrhaging. So basically what you have is in the middle of your chest you have bloody pus.
Bloody pus is right. To go more into detail, the anthrax spores are first absorbed through the lungs and into the bloodstream, where they are eaten up by macrophages, a special type of white blood cell in the immune system. A macrophage, however, doesn't have quite the right stuff to completely digest and destroy the spore, so it functions as a kind of taxi for the spore as it makes its way to the lymph node in the chest, a kind of jail cell for pathogens to keep them from infecting the rest of the body. The spores germinate in the macrophage and begin producing their